Let's do another example. A trainer is investigating whether the proportion of cross-country athletes and basketball athletes who can perform pull-up differs significantly. Previous studies suggest that basketball athletes generally have a higher proportion of success in pull-ups than cross-country athletes, but a researcher wants to test whether this difference is statistically significant. So a random sample of 90 cross-country athletes was tested, and 45 successfully completed a pull-up. A random sample of 80 basketball athletes were tested, and 56 successfully completed a pull-up. So the researcher tests the difference in proportions at alpha equals 0.05. All right, so let's write down the pieces of information that are relevant. This is the difference in proportions, so we're going to test for the difference in proportions. The sample size for cross-country runners, N1, is 90. Sample size for basketball players, or N2, is 80. The sample proportion for cross-country runners, so P hat 1, we're going to take the number 45. That's the number of successes over sample size. 45 over 90, we get P hat 1 is 0.5. And for sample proportion for basketball players, we're going to have 56 over 80, which is 0.7. Now we also want to write down the null and alternate hypotheses. So the null is always that the two proportions are the same and that the difference is equal to 0. And the alternate we'll have to think a little bit more about. So it's always going to be the difference. And so it's a little bit obscured what we're going to put in the alternate, but the athletes, basketball athletes generally have a higher proportion of success. And what the researcher is wanting to show is that it's significantly higher. So they're wanting to show that basketball proportion is going to be higher than the cross-country proportion. So that means that our P1, which is the cross-country proportion, is less than the basketball proportion. So that would mean that the difference would be less than 0. All right, because this corresponds to, it would be the same as if we said the proportion of cross-country is less than the proportion of basketball. All right, so two ways of saying the same thing. So we have a left-tailed test, so we can maybe make a note of that. Left-tailed test, because we have a less than in our alternate. So let's do the check of the assumptions. So to do that, we need the pooled proportion, so P pooled, or PP, which we're going to take the sum of the success, 45 plus 56, over the sum of the sample sizes, 80 plus 90. So 101 over 170, which gives us a pooled proportion of 0.59. And with that, we can test for normality. So we want the number of successes both to be greater than 10, and also the number of failures. So we're going to use the pooled sample size, so 170 times 0.59. So the pooled sample size times the pooled proportion, which is about 100. So that's clearly greater than 10. And then our pooled sample size times 1 minus the pooled proportion. So 1 minus 0.59, which is 0.41. And that equals approximately 70, also greater than 10. So check, we can use normal distribution. So let's calculate some things now. Calculate the standard error. So it's our big square root. We're going to take the pooled proportion times 1 minus that, times, in parentheses, 1 over the first sample size of 90 plus 1 over the second sample size of 180. So we get, plugging that in the calculator, we're going to get standard error of 0.076. So now we can calculate the test statistic. So we're going to take the difference in the sample proportions. So 0.5 minus 0.7. And that's subtracting the 0 from the null hypothesis. And then that's over that sample, or that standard error, 0.076. So that's going to give us a negative 2.63 for our z-score. And if we look at finding the p-value, so remembering that we have a left-tailed test, so here's our z-value, negative 2.63. So the area is this here. That's our p-value. And from the table, we see that we have p-value of 0.0043. All right, so that's our p-value. All right, so the conclusion for step 4 would be that we are going to reject the null hypothesis, and that is because our p-value 0.0043 is less than the significance level of 0.05. So what that means is the proportion of basketball players that can complete a pull-up is significantly higher than the proportion of cross-country runners that can complete a pull-up. So we would say that this has significant results. So the proportion for basketball is higher than for cross country.